Afternoon, everybody. How many of you here have ever wondered why you are taking calculus? How it's going to like be applied outside of the classroom? Are you just taking it to get the grades, or there will be like kind of a benefit when you will get out of school? I have. I really. How many? Oh, okay. So almost everybody here. Well, let me tell you, calculus has great applications. It ranges from sciences to economic systems. So it's kind of everywhere. And according to a standard calculus textbook by George Thomas and Ross L. Finney, calculus and calculus no biologists use calculus to forecast population size and to describe the way predators like foxes interact with their prey. Drug companies also use calculus to determine profitable inventory levels. Economists also use calculus to forecast global trends. So we can see that it has like a lot of uses application out just outside of school. So and the list goes on and on and on and on. So my name is Wilfried Cassie, and my partner Juan David Bibas and I are going to focus more on the applications of calculus in sports. So first, we are going to give you a little bit of background of calculus, and then talk about the application of calculus in basketball, and then transition to the application of calculus in soccer too. Okay.
Um, so for this presentation, you can actually take your cell phones out, please, if you can. This is part of an interactive activity with our presentation that we will be having. So I know that Professor Dagan tells you to not take your cell phones out, but I'm telling you to take your cell phones out throughout our presentation here.
Okay. So are you guys ready? Phones up. Okay. So I was telling you earlier that we are going to start with a little background of calculus. So I'm a little bit familiar with the calculus history, actually, because of Professor Degan here. Since pre-calc, every semester, he's going to take a 5-minute break between two like theorems to talk about Newton and Leibniz and the fight, the controversy, who created calculus, who didn't. Is with one of them, he doesn't think that the other one created, blah blah blah. You know the story. So those two men really are considered the pioneers, if we can say, of calculus. The funny thing is that they never like got together to like work together, think about calculus, created, but in their own way, and they use like a very different. They have a really different approach on the subject, but at the end, their minds converge to the same ideas. They never met, never talk to each other, say, oh, okay, let's sit down, let's work on this problem here and try to figure out something. But at the end, don't know, it's funny to me. So at the end, they had the same ideas and different approaches, but still the same result. So in the development of calculus, both Leibniz and Newton used infinitesimal. So those are really small quantities that are like very small, like close to zero, but they are not zero. So I don't know if those kind of quantity exist, but hey, it worked for them. It was convenient. They solved whatever they had to solve with this kind of mindset. So according to the University of Iowa website, Leibniz introduced dx and dy as differences between successive values of these sequences. He knew that dy over dx gives the tangent, but it did not use it as a defining property. On the other hand, Newton used quantities x prime and y prime, which were finite velocities that help him compute the tangent. And neither Leibniz nor Newton knew exactly why what they were doing was working, but it was working. I think that it was like based off on everything that I read. I think it was mostly based on intuition, but hey, it worked for them. So they didn't really think of everything that they found in terms of function. They solely looked at just graphs. So that's, yeah, they didn't think of like, okay, let me find a function that will help me solve this problem. They just looked at graph. So for Newton, calc was geometrical, while Leibniz took it toward analysis. The controversy that Professor Degan is always talking about is that Newton started working on calculus like around the 1660s, something like that, but he didn't like publish his papers in the 1680s, and Leibniz started like around 1670s and published his work in kind of the same year. So the question is that who created calculus? So that's what the controversy is about. So yeah. So did you guys answer to this question?
Yes.
Okay. Now that I'm done talking with the background. So how many years? So here 67% of you guys say that they know the definition of calculus. So who can give me the definition of calculus? The 60s, between the 67%.
That man.
Except Professor Degan, because I didn't know exactly what calculus was used for till this research, this project. So yeah, the 71%. Yeah, tell me.
You cheater.
No, yeah. Yes. So after all the research that we did, we found that so according to the University of Otago, it's in New Zealand, calculus is the mathematics of rate of change. In the same way that geometry is the study of shape, and algebra is the study of operation. So there are two types of calculus. There are integration calculus and differential calculus. So this is kind of a small information. When we were doing the project, I asked myself, what is calculus? I've been taking so many classes, but I didn't know. And hopefully the University of Otago website gave me like a good idea of what calculus was. Okay, so those are kind of some applications of calculus. Newton's laws and scalar and vector quantities. Those are just some of the applications of calculus that can help us in understand sports more.
And okay, being said that these are only applications, we know we can apply calculus in many different ways, but these are specifically for the two sports that we will be talking about.
Yep.
So the first one we have, you know, the basketball. And then my friend here will mention a little bit about basketball. And It's an Ivory Coast thing, guys. Don't worry
Yeah.
about it.
Okay. So that being said, I'm going to talk to you guys about the applications of calculus in basketball. So we know that everything moves. Everything on Earth goes from rest to motion. So how do you explain this motion? Then calculus is the answer. So you have those equations that you just saw. Right? Yeah. So those equations can help you. and yeah, I know that you want me to see the right. It's good. So those equations that you saw will help us like understand some of the moves. And you know that in basketball, the most important thing is moving the ball around. So how do you give an explanation to that? The passes, the shots, everything. So I'm going to put the equations back. It was x of t equals v0t plus x0, and the other one was y of t equals 1/2 a t squared plus v0t plus y0. So here v0 is the initial velocity of the ball, of the shot. x0 is the initial position. A here is equal to minus j, which is 9.8 meters per second is the acceleration. Oh, but j is not the acceleration. V0t, same thing. Y0 is the initial position on the y-axis. So that's the problem that we have here. A basketball player is standing on the floor 10 meters from the basket as shown, and the height of the basket is 3.05 meters, and he shoots the ball at 40-degree angle with the horizontal and from a height of 2 meters. Calculate the following, and what we are looking for is the initial velocity here. Okay, so we have the position, we have the angle here, so we can compute the velocity from that. Okay, so this first equation will give us that. So x of t, I'll just put x. So x minus x0 is actually the position of the ball after it leaves the player's end, equals v0t. Then t, which is the time, will be the position of the ball over the velocity after a certain period of time. And here we know that the position of the ball is 10 meters since the basket is 10 meters from the player. So that's, it will be, we can put 10 over velocity here. So y of t, we have 9.8, which is a is negative g. So 9.8 divided by 2 is 4.9. So here, so y minus y0, which is always the position on the y-axis, will be minus 4.9 t squared plus v0t. Okay, here we have an expression of t. So we put it back here. So y minus y0 equals minus 4.9. And here, for the velocity is on two axes. Here I forgot to put v0. So that's the velocity v0. You have the x-axis here and the y. So on the x-axis is v0 sine. I forgot to put that. Cosine, sorry. Cosine. The angle, cosine. And on the y-axis, this v0 is v0 sign. Okay, so we'll have t is 10 over v0 squared plus v0 sine theta over t, which is 10 and here we can simplify those two and bring it 10 tangent, and y minus y0 is 3.05 meters. So after replacing everything by its value, we have the angle, which is 40 degrees, and we solve for the velocity. For the initial velocity, we'll get that it's 10.7 meters per second. Okay, so now we are going to try to see if this number will work. So I have a simulation here. So the basket, let's say the rocket launcher is the basketball player and this is the basket. So it's 10 meters from the player. And 3 meters high. Sorry. .305 high, so we'll put it at 305. I think that will be fine. Okay, here. And the ball is 2 meters high from the So we asked you guys, so if we put those numbers in, how many of you think that the ball is actually going to hit? So we have 40 degrees, we found 10.7. So how many of you do you think that the ball will hit?
I believe in you, Will.
So
Wait, I want to put
Yeah, you can just put
Okay, so according to you, 67% that said that the ball will not hit, and 33% said, I don't know, my BFF Joe. So we are actually going to see if it will hit or not.
okay.
As we fire it, go ahead and fire it. And voila.
Okay.
So all of you failed because none of you answered that it would hit the target.
Put it back.
I just did.
Come on,
I
put
did.
it back.
Oh.
Put it back and
Oh,
see.
well, making me like feel.
Oh,
okay, good. 13% of you actually
Yeah.
said that it would hit the ball.
Thank you.
Thank
you
so
for the
congrats
Oh,
to
that's
those
three. Okay.
13% of people that actually passed this. Okay, so we're gonna go ahead and continue.
Yes.
One person voted after the fail
And-
is cheating.
So yes, and
Oh, here we go.
before one
It's gonna take a few seconds.
one continues, like equipment manufacturers also use calculus in order to form like all the balls that you see here. For example, the tennis racket. you need to have the like maximum sweet spot area. So the sweet spot is the area of the racket that will give you the maximum power or the right vibration to the player. So you can translate all this information into calculus equations in order to find what the right area and the right and the right vibration will be for a specific player. So yes, now I'm going to now my partner Juan is going to inform you about soccer, calculus and soccer.
You want me to continue?
No, next week.
And that is our. We will continue next week with our presentation because of time management. So definitely, I'm gonna be talking about soccer and everything that has to apply with soccer and the physics in soccer next week. We still have more polls that you guys can fill out. So please, we would like to see you next week here. And we are done for now.
Thank you.
Thank you.